Welcome to Real-Time Signals. Today we are going to discuss about K-means algorithm, which is an unsupervised learning. Before we talk about K-means algorithm, let's take a look at unsupervised learning. Unsupervised learning is a way of learning machine learning where we do not know the exact output. We will be learning the outputs as and when we are working on the algorithm. So, for example, there is an analogy. You have set of documents and you want to organize them in certain order of the categories. Given such document, just document and no other information, can you discover the meaningful categories of documents? No. Then with so how do we do that? That is what unsupervised learning. And this makes your life easy. Next time when you come back, if you have certain categories, you can definitely choose to go for that, and that search makes it easy. Another analogy here, say you are running an online shopping and you do not have much information about people, their likes, their dislikes. What you know is their name, age, or maybe address. So, based on their previous shopping, you can choose category, you can put them different categories, which can be helpful for you to run marketing campaign or suggest them whenever they come next time, suggest them a product which may they like. So let's take a look at a data set. Here, this is a two-dimensional data set. Here you can see data points. On easily as a human, you can just make out that there are three categories. But when you receive a data point, you may not be pretty sure about it. So you have to run an algorithm. Let's understand clustering before we go into K-means algorithm. So first thing, you have to quantify the similarity. You got data points and you have to quantify the similarity, and you find out, okay, these are the data which belongs to this cluster. So you have to find out the similarity. How do you do that? You find the distance between data points. First thing, you find the median of a cluster. From that median point, how far is your data point, that is called as equilibrium distance. You find the equilibrium distance, and from that equilibrium distance you can then you can always go for the nearest cluster for each incoming data points. Now let's go for K-means clustering. First thing, group data into K number of clusters. These K number of clusters are heuristically chosen. It depends on your application. You can go for either number, but generally when you are going for an application, you have a fair idea how many clusters you want to go for. For each cluster, you have to and you have to categorize them by mean or a centroid. Each data point is assigned to only one cluster. Then define error as the distance of data point from the mean of the cluster to which it is assigned. Find cluster means such that the sum of errors for all data point is the smallest. Okay, we are back to the same problem here. You can see data set. All the data points there are on the middle, top, on the right, and on the left. Now first thing what you do in K-means algorithm, you choose to go for clusters. Here I've gone for 3 clusters because I have a fair idea depend on my application that there are going to be 3 clusters. And these 3 clusters I've picked as 3 data points: blue, brown, and green. From blue, brown, and green we find the equilibrium. From that equilibrium distance, whichever we find equilibrium distance for all three centroids, all three median values for all the data sets. For all the data point, whichever data point has got the least equilibrium distance from that median, you categorize them in one cluster. For example, the blue one here is, you can see the previous one here, the blue one, you can see the 4 on the left side will be definitely having less equilibrium distance with the blue one, and the brown one here, the one on the left on the top will be closest to brown, and the two on the top are going to be closer to the green. And below on the right side there will be some of them which will be closer to brown, some of them will be closer to green. Ideally this is not what you want, so now what we should do? Okay, we'll go and find median one more time, but this time around when we find median we are going to do an average of all the data points and put a median according to the average of data point in that cluster. Here you go. Now you can see the blue one is right on the middle of the cluster. The brown one has gone little bit on the right side, and green one has gone further right. Now let's find the equilibrium distance. You can see blue one, no confusion. Brown one also, all of them are getting into a single cluster, and the green one also. But still there is something which we don't like, the median point. Median point, the green median point should have been in the center, and the brown should have been in the center. So what we do, we again find the median or the centroid of the cluster. How do we do that? We take an average of all the data point in that cluster. Okay, here you go. So we get exactly in the middle of all the data points. The blue one is in the middle, brown one is in the middle, and green one is in the middle. And here now you can see this is how all of the data points are getting into 3 different clusters. Now if we receive a new data point, what do? We find the equilibrium distance from all 3 cluster medians, and whichever equilibrium distance is less, we will put that data into the cluster, into that category. Okay, so the steps in K-means. Choose k-random data points as means, and how many k-random data points you are going to choose, how many clusters, however cluster you want. Every time compute distance of each data point to all cluster mean. Assign data points to the nearest cluster. Again update the mean and repeat it. Repeat it. How long you have to repeat? You have to repeat that minimum equilibrium distance you should achieve to go for minimum equilibrium distance of sum of all your data points. Now this is a sample code in Python. Input data is coming in X, and there are 3 labels of cluster 0, 1, 2, and we find the error function, which is basically the equilibrium distance, and we put them into a loop, and we do find the equilibrium distance, and then we find the average of each data point, find a new median, again repeat, find the equilibrium distance, and ultimately you should have 3 clusters out of this. That's it. Thank you very much.